We all think we have a pretty good idea of what makes a gemstone strong. We hear all the time that diamonds are the hardest thing on Earth, and we just assume that means they're, well, indestructible. But what if I told you that the way we use words like hard and strong in daily life is totally different from what they actually mean in the world of gemology? All right, let's get into it and shatter a few of those common myths.
So let's just start with what seems like a really simple question. What's the difference between something that's hard and something that's soft? You probably have an answer right on the tip of your tongue. But trust me, the scientific answer, well, it's a bit of a curveball.
Okay, so check this out. This is where things get really interesting. And our everyday ideas get flipped upside down. We all think of a feather as soft and glass as hard, right? But in gemology, a gemologist would tell you that glass is actually pretty soft. So soft that tons of other materials could easily scratch it. And that right there, that's our first big clue that we need a whole new set of definitions. And that new definition is surprisingly simple. In science, hardness means one thing and one thing only: the ability to resist being scratched. That's it. It has nothing to do with being unbreakable. It's all about how tightly the atoms inside a material are bonded together and how well they can fight off being separated into a scratch. So from now on, when a gemologist says hard, what they really mean is hard to scratch. So if hardness is all about scratchability, how do we actually measure it? How do we rank one gem against another? Well, that brings us to a tool that's been the industry standard for more than 200 years. Say hello to the Mohs scale. It was created way back in 1812, and it ranks 10 common minerals from the softest, which is talc at number 1, to the hardest. And the rule is super simple. Any mineral on the scale can scratch another mineral with a lower number. So topaz, sitting at an 8, can scratch quartz at a 7, but it can't put a dent in corundum, which you probably know better as ruby and sapphire at number 9. Seems straightforward, right? Well, there's a huge catch. And this right here is the big secret of the Mohs scale, the part that changes everything. It's not a nice, even ladder where every step up is the same size. It's what's called an ordinal scale, which just means the numbers are a ranking: first, second, third, and so on. The actual gap in hardness between a 1 and a 2 is tiny, but the gap between a 9 and a 10, it's absolutely massive. And you can really see just how steep that curve gets when you look at it like this. Corundum, which is number 9, is already twice as hard as topaz at number 8. But that jump from corundum to diamond at number 10, it's just in a whole different league. It's not just a little bit harder. It's 4 times harder. A diamond is 4 times harder than a ruby or a sapphire. Think about that. They're just one number apart on the scale, but in reality, there's this enormous leap in hardness. That incredible resistance to scratching is why a diamond, and only a diamond, can actually scratch another diamond.
Okay, so we've established it. A diamond is off the charts hard when it comes to scratching. But this is where we finally get to the very heart of the myth, because being the hardest does not mean it's the toughest, not even close. And this is the great paradox. A steel hammer, it's about a 5 or 6 on the Mohs scale. If you were to drag it across the face of a diamond, you wouldn't leave a single mark. But if you take that same hammer and give that diamond a good whack, it can completely shatter. This tells us we're missing a piece of the puzzle. We need another property to explain what's going on here. And that missing piece is called tenacity. The easiest way to think about tenacity is just toughness. So while hardness is all about fending off surface scratches, tenacity is about how a gem stands up to an actual impact. It's the real difference between a material that scratches and a material that breaks. So when you put these two concepts side by side, you start to see this fascinating trade-off. A diamond has the ultimate hardness, yeah, but lots of other gems are way, way tougher. Jade, for example, is legendary for its tenacity. You can carve it into these incredibly delicate, intricate designs and it won't break. But on the other end of the spectrum, you have a beautiful gem like zircon, which is known for being super brittle. It can chip really easily, even though it's actually pretty hard. So how is this possible? Why can the hardest substance on the planet be shattered? Well, the answer lies in a kind of hidden weakness, almost like a structural grain that runs through a lot of crystals. And the best way to get your head around this is to think about wood grain. We all just instinctively know this, right? It's way easier to split a log with the grain than it is to try and chop across it. Well, it turns out that a lot of gemstones have a hidden internal structure that works in exactly the same way.
In gemology, this grain has a name. It's called cleavage. What it is a natural, perfectly flat plane inside a crystal where the atomic bonds are just a little bit weaker than they are in other directions. So a sharp tap right on that plane can cause a perfectly clean split. And just like with tenacity, gemologists have a rating system for cleavage. A gem with perfect cleavage, which includes diamonds, will split very cleanly and easily if it's hit in just the right spot. But a gem with poor or none, like quartz, for example, is much more likely to just fracture in a random, jagged way instead of splitting neatly. You've probably seen this in old movies, right? The master diamond cutter studying a huge rough diamond for days, finding that one perfect cleavage plane, and then, with a single, precise tap of a mallet, splits the stone into two flawless pieces. That's a perfect demonstration of using a diamond's cleavage. For a cutter, it's a gift, but for someone wearing it, it's also its greatest vulnerability to an accidental bump. Okay, I know. That was a fair bit of science, but it all really boils down to one very practical question. Why does any of this, hardness, tenacity, cleavage, actually matter when you're picking out a piece of jewelry? Well, it matters because the biggest enemy your jewelry is going to face day in and day out isn't some dramatic hammer blow. It's something much, much smaller. It's dust. You see, common household dust is mostly made of tiny particles of quartz, which, as we saw in the Mohs scale, sits at a solid 7. And this brings us to the ultimate, all-encompassing idea, wearability. This is the term that pulls everything we've talked about together. A gem's wearability is its total ability to stand up to the daily grind, to resist those scratches from dust, to survive the accidental knocks, and to keep its beautiful, shiny finish for years and years. So let's put it into a real-world scenario. Let's say you have an opal ring. Opal has a hardness of around 6. That means it's softer than the quartz in common dust. Every single time you wipe that ring clean, you're actually creating thousands of microscopic scratches that over time will make its beautiful surface look dull. Now compare that to a ruby ring. A ruby is a 9 on the Mohs scale. It's much, much harder than that dust, so it's going to resist all those daily scratches and stay sparkling and brilliant for a lifetime. That right there is wearability in action. So the next time you hear someone describe a gemstone as strong, you'll know to ask the right questions. Is it hard or is it tough? Does it have perfect cleavage? You're not just looking at a pretty stone anymore. You're looking at a fascinating piece of material science. So the real question is, now that you're armed with this knowledge, what will you value most?